In the summer of 1958, something unprecedented unfolded over the South Atlantic Ocean. Something so secret, so radical, that for decades its full scope remained obscured beneath layers of Cold War classification. High above Earth, beyond the reach of ordinary conflict, the United States conducted one of the most audacious military experiments in human history. It was called Operation Argus, a top-secret mission in which the US Navy detonated not one, but 3 nuclear warheads in space, not in the desert, not beneath the sea, but above the planet, in the fragile interface between Earth's atmosphere and the void. The goal was not immediate destruction, but disruption. To weaponize radiation itself, the plan was to create artificial belts of charged particles around the Earth, to scramble Soviet radar, blind early warning systems, and potentially change the rules of strategic warfare forever. But the implications of Argus reached far beyond radar interference. The tests not only succeeded in their military objectives, they altered Earth's near-space environment, triggered international scientific alarms, and permanently rewrote what was possible in the realm of atmospheric and orbital manipulation. This is the story of the radiation ring no one told you about. The year was 1958, and the geopolitical climate was electric. Just 1 year earlier, the Soviet Union had launched Sputnik, the world's first artificial satellite. Its steady radio pulses, heard by amateurs and militaries alike, sent shockwaves through the Western world. To many in Washington, it was more than a scientific achievement. It was a signal of orbital superiority, a declaration that the high ground of space was no longer a dream, but a battlefield. The US response was immediate and multifaceted: accelerate space exploration, increase defense spending, and prepare for a new kind of warfare. One fought above the clouds, in an arena where treaties did not yet exist. It was in this climate of urgency and escalation that Argus was conceived. Developed under extreme secrecy by the US Department of Defense and executed by the US Navy operation, Argus took place aboard a rapidly assembled task force in the South Atlantic. The core vessel was the USS Norton Sound, a ship already involved in classified missile tests. This time, however, it would serve as a launch platform for suborbital nuclear missiles. The logic behind the operation was deceptively simple. Scientists had theorized that by detonating nuclear devices in the upper atmosphere, they could release enormous quantities of beta particles, electrons accelerated by the explosion. These particles, if placed properly, would become trapped by Earth's magnetic field, forming temporary artificial radiation belts. These belts could, in theory, interfere with radar and radio signals, disrupt missile guidance systems, and blind any Soviet effort to track or coordinate attacks. In short, Argus was not designed to destroy. It was designed to distort, to turn Earth's magnetic shield into a weapon. To accomplish this, Argus relied on 3 nuclear warheads, each launched via X-17A missiles to altitudes exceeding 480 kilometers, far above commercial flight paths and within the very threshold of outer space. Detonations occurred at precise intervals, with instruments aboard ships, aircraft, and even satellites monitoring the aftereffects. And the results were immediate and stunning. Each explosion released vast clouds of high-energy particles into the upper atmosphere. As predicted, Earth's magnetosphere captured these particles, suspending them in orbit. Radiation levels spiked, electromagnetic pulses surged across test sensors. The Van Allen belts, the naturally occurring zones of trapped radiation around Earth, were briefly expanded by artificial means. For a few fleeting weeks, the planet's magnetic armor bore the fingerprints of human interference. What Argus proved was shocking. Nuclear radiation could be sculpted, not merely used to destroy infrastructure or incinerate populations, but harnessed, directed and suspended in space to alter Earth's geophysical environment. This wasn't science fiction. It wasn't theoretical. It happened. The sky glowed with auroral light, artificial dawns visible in the South Atlantic night. Instruments on the ground recorded anomalies that extended far beyond the blast zone. Satellites experienced electrical disturbances. Atmospheric sensors picked up distortions in the ionosphere, the crucial layer of charged particles that facilitates long-range radio communication and reflects radar signals. Scientists were both thrilled and alarmed. Among them was Dr. Nicholas Christopoulos, the physicist credited with initiating the concept. Christopoulos had long theorized that Earth's magnetic field could be manipulated using particle injections. Operation Argus was, in part, a validation of his vision, but even he acknowledged that the scale and intensity of the actual detonations produced results that exceeded expectation and risk. The artificial radiation belts, though temporary, posed new questions. What would repeated detonations do to the planet's electromagnetic integrity? Could these belts drift, expand, or decay unpredictably? Would they pose a hazard to satellites, astronauts, or even future communications infrastructure? At the time, no one could answer, but the military classified the operation as a resounding success. The ability to degrade or disrupt Soviet communications using high-altitude nuclear blasts was now more than theoretical. It was operational. And though Argus was never repeated at full scale, its lessons informed numerous follow-up projects, including Starfish Prime, Hardtack, and other nuclear tests in space conducted in the early 1960s. None of these tests were made public at the time. The world remained largely unaware that for a brief moment, the United States had reprogrammed the sky, and in doing so, had opened a new chapter in environmental warfare. And while the public looked up and saw stars, the military saw vectors, payloads, and opportunity. While Operation Argus remained hidden from public view, the effects of its detonations could not be fully contained. The electromagnetic reverberations of those high-altitude nuclear bursts were not limited to the South Atlantic. They resonated across the planet, registered by scientific outposts, intelligence stations, and unwitting researchers alike. From the moment of the first explosion, instruments around the globe lit up with anomalies. Radio blackouts rippled across unexpected frequencies. Seismic readings spiked in unexplainable ways. Weather monitoring equipment from Norway to New Zealand reported unexplained atmospheric fluctuations. Even the Soviet Union, monitoring closely through their own early warning networks, knew something unusual had happened. Yet no public statement was issued. No news bulletin reported that 3 nuclear devices had just been detonated in space. The military sealed Argus beneath a blanket of operational necessity, and science was folded back into secrecy. But silence doesn't prevent consequences, and the scientific community, especially those involved in space research, began asking difficult questions. Dr. James Van Allen, the same physicist after whom the natural radiation belts were named, had played a peripheral role in monitoring high-altitude particle behavior. Though not directly informed of the mission's classified intent, his team's satellites detected the formation of the artificial belts almost immediately, and the results disturbed him. The particles released by the Argus detonations did not simply vanish. They persisted, forming temporary, man-made radiation zones that posed risks to orbiting instruments and, in future scenarios, to manned spaceflight. Satellites in low Earth orbit began experiencing electrical disruptions, early signs of what would become a major technical challenge in the space age: radiation-induced degradation. Van Allen warned that such tests, if repeated, could destabilize Earth's delicate electromagnetic environment. But few outside the Defense Department had access to the full scope of data. Even fewer had the clearance to speak. One group that did notice and took action was the Soviet military. The USSR had long suspected that the United States was exploring high-altitude nuclear applications. But Argus confirmed their worst fears. Intelligence intercepts, paired with scientific irregularities observed by Soviet physicists, indicated that the US had developed a method to weaponize near-Earth space. Not with orbiting bombs, but with energy itself. And so the Soviets responded in kind. By 1961, they had conducted their own upper atmosphere nuclear tests, some reaching altitudes even higher than Argus. The K project, as it was later called, involved detonations of megaton-scale devices above Kazakhstan. These explosions created longer-lasting radiation belts than Argus and resulted in widespread satellite failures, even damaging Soviet assets unintentionally. The Cold War was no longer a contest of arms alone. It had become a battle of atmospheres. What Operation Argus had revealed, both to its creators and its enemies, was that the ionosphere itself could be militarized. And once that realization took hold, it became a permanent feature of defense planning. But this revelation wasn't only of interest to generals and physicists. It intrigued visionaries and conspiracy theorists who saw in Argus the genesis of environmental warfare. And their questions weren't entirely misplaced. Documents declassified in the 1980s revealed that several US defense contractors, including those involved in Argus, began drafting proposals for electromagnetic manipulation of the ionosphere. These concepts, once theoretical, matured into programs like Project Sanguine, Project ALF, and eventually HAARP, the High-Frequency Active Auroral Research Program. Officially, HAARP was designed to study ionospheric physics. Unofficially, it carried the fingerprints of Argus: large-scale arrays, high-frequency radiation, and experiments in altering global communications infrastructure. Critics, including scientists like Dr. Rosalie Bertell, warned that HAARP and its predecessors were part of a lineage of experimentation that began with the detonation of nuclear devices in space. Their concern was not about weapons in the conventional sense, but about control, of information, of weather patterns, of global perception. Because if radiation could be sculpted, as Argus proved, then the possibilities for manipulation were profound. But these warnings, too, were buried. For decades, the official narrative around Argus was limited to a footnote in Cold War history. At best, a technical achievement. At worst, a harmless test. The reality was far more complex. One haunting consequence that emerged over time was the degradation of early satellites. The Explorer 4 satellite, launched by the United States to monitor radiation, encountered unexpected interference. Its sensors were overwhelmed by the lingering effects of the detonations. Several Soviet satellites suffered critical failures in the months following Argus and the K project, failures initially attributed to mechanical error, but later linked to elevated radiation zones. And while Argus detonations were of relatively low yield, 1.7 kilotons each, their strategic implications were massive. Military planners now knew that even small-scale nuclear devices detonated at the right altitude could cripple orbital infrastructure. This knowledge seeded the doctrine of electromagnetic pulse warfare, EMP. The concept, detonate a nuclear device at high altitude over a region, not to destroy cities, but to disable electrical grids, satellites, and communications. The explosion would create an EMP, a burst of radiation that surges through unshielded systems, frying circuits and plunging entire regions into technological darkness. In a future conflict, a single atmospheric detonation could erase modern infrastructure, without a single building being touched. Argus didn't just suggest this, it demonstrated it. And once that genie was out of the bottle, it was never going back in. Yet the public knew none of this. To the average citizen, 1958 was a year of scientific optimism. The dawn of NASA, the race to the moon, and peaceful visions of satellites dancing across the night sky. No one was told that nuclear devices had been detonated in the very domain that would one day host astronauts. That silence, intentional, institutional, was the real legacy of Argus. Because what Argus ultimately revealed was not just that the sky could be weaponized, it revealed that governments would do it, and hide it. As the artificial radiation belts of Operation Argus began to dissipate, one thing became clear: humanity had crossed an invisible line. The detonation of nuclear weapons in space had proven that we could alter Earth's natural systems, not just on the ground, but in the very electromagnetic fields that shield and sustain life. And yet, no treaty was signed, no international condemnation followed. The sky remained a blank canvas, and those who held the power to shape it chose secrecy over dialogue. In the years that followed, the implications of Argus spread in subtle, far-reaching ways. Though the temporary belts decayed, their effects echoed through military doctrine, scientific research, and global policy. No longer was space merely a domain of observation. It was a potential battlefield, and Earth's upper atmosphere a medium for weaponized interference. Argus was the unspoken ancestor of countless space-age advancements. The same principles that had been tested in secret would later guide the development of directed energy systems, space-based missile interceptors, and concepts like environmental modification weapons, methods of altering planetary systems to produce military outcomes. In 1977, the United Nations Convention on the Prohibition of Military or Any Other Hostile Use of Environmental Modification Techniques, AINMOD, was adopted, banning the use of environmental manipulation as a weapon. But by then, much of the groundwork had already been laid. Argus was proof of concept, and its legacy lived on behind classified doors. The early space program, too, bore its fingerprints. When President Kennedy gave his famous speech pledging to land a man on the moon, few knew that the very environment NASA planned to send astronauts through had, just a few years prior, been saturated with weaponized radiation. The same belts that Van Allen had studied, expanded and distorted by Argus, were now part of mission planning. Astronauts would need shielding, flight paths would need adjustment. In this way, Argus quietly influenced the logistics of Apollo, Mercury, and Gemini. The technology to reach the moon was not born in peace. It was forged in the crucible of nuclear experimentation. Even as NASA promoted messages of exploration and international cooperation, the reality was far more entangled. The same launch facilities used for lunar missions were also tested for missile deployment. Many of the engineers who calculated Apollo trajectories had backgrounds in defense, and the radiation environment they had to navigate was shaped in part by the very detonations no one talked about. But not all consequences were technical. Some were deeply philosophical. Argus posed a question that no one in 1958 was ready to answer. What happens when a species gains the power to alter planetary systems, and does so in secret? It wasn't just a question of capability. It was a question of ethics, of restraint, of oversight. And those questions remain unanswered. The long-term health effects of nuclear atmospheric testing, though primarily attributed to surface detonations, remain debated. But what about space detonations? What about prolonged radiation exposure for high-altitude pilots, early astronauts, or airline crews flying near polar routes during tests? Records are incomplete, data remains classified, and where transparency ends, speculation begins. Today, conspiracy theories circulate about Argus and its alleged connections to weather manipulation, EMP readiness, and even mind control. While many of these claims are exaggerated or unfounded, they share a common root: the institutional silence that surrounded the program. A silence that bred mistrust, because once people learn that nuclear weapons were detonated in space without their knowledge, it becomes harder to dismiss claims of continued manipulation. And Argus wasn't an isolated moment, it was part of a pattern. In 1962, just 4 years after Argus, the US conducted Starfish Prime, a much larger nuclear detonation at 400 kilometers altitude. The resulting EMP knocked out streetlights in Hawaii, damaged satellites, and painted the sky in surreal auroras. It confirmed what Argus had only hinted at, that the line between atmospheric science and military ambition had been irreversibly blurred. Today, Argus remains largely unknown to the general public. It's a footnote in Cold War history books, if mentioned at all, but its fingerprints are everywhere. They're in the protocols for satellite shielding, they're in the policy documents on space warfare, they're in the silent corridors of facilities that never received public tours, and they're in the cultural memory of a generation raised to look at the stars and see possibility, without ever being told what had already been done in the name of power. But Argus also left behind a deeper legacy, one etched not in data, but in precedent. It proved that a government could conduct high-risk, high-impact experiments on a planetary scale, and keep them hidden. It proved that the skies could be rewritten, not by poets or astronomers, but by military strategists with fuses and launch codes. It proved that reality could be altered without consent. And in doing so, it raised a final question. If we can sculpt radiation into belts, if we can detonate the sky and reshape the magnetic field, what else have we done? What else has been written into the air, above us, around us, and beyond our reach, without our knowledge? The story of Operation Argus is not a warning, it is a record. It tells us that the sky is not immutable, that what surrounds us is not always natural. That power, when unchecked, reaches not just across borders, but into the very physics of the Earth itself, and that sometimes the most lasting scars are the ones we were never told about. Welcome to the Forbidden Index,